The Hubble Space Telescope was developed by NASA and ESA and named after astronomer Edwin Hubble. It works in the range of the electromagnetic spectrum from the infrared range over the visible light up to the ultraviolet range. The mirror diameter is 2.4 meters. The Hubble Space Telescope was launched on April 24, 1990 on Space Shuttle mission STS-31 and was deployed from Discovery's cargo hold the next day. After deploying the telescope, the image quality did not live up to expectations. A failure of the primary mirror resulted in images that were practically useless. 3 years later, in 1993, the error was successfully corrected with the help of the COSTAR mirror system. Let's take a look into the becoming of that failure and what solution scientists finally came up with. The first serious concept of a scientific telescope in Earth's orbit was presented by Lyman Spitzer, then a professor at Yale University in 1946. He underlined the then unavoidable disturbances by the Earth's atmosphere, which limited the resolving power of any Earth-based telescope. In addition, the atmosphere also absorbs all X-rays, making the observation of very hot and active cosmic events impossible. As a solution, he proposed a telescope in Earth's orbit outside of the atmosphere. Some time later, the National Academy of Sciences approached Spitzer, now teaching at Princeton University, to hire him to chair an ad hoc committee to design a large space telescope. During the first meeting in 1966, extensive studies were made for the use of such a telescope. 3 years later, a paper entitled Scientific Uses of the Large Space Telescope was published, in which the committee called for the construction of such a telescope as it could make a substantial contribution to our knowledge of cosmology. The next step was to secure government funding for the project. Due to the high price of $400 to $500 million, about $2 billion in today's value, the first proposal in 1975 was rejected by the Budget Committee of the House of Representatives. After some lobbying and cooperation with ESRO, a predecessor organization of ESA, to finance the solar cells and the additional reduction of the primary mirror from 3.0 to 2.4 meters, the price was reduced to around $200 million. The new concept was approved by Congress 2 years later, allowing work on the new telescope to begin. The most important orders were placed in 1978. Perkin-Elmer was to construct the optical system including the primary mirror. Lockheed was responsible for the structure and the satellite bus, with the solar cells and an instrument being made in Europe. Due to the importance of the primary mirror, Perkin-Elmer was also instructed to use a subcontractor to fabricate a backup mirror in case of damage. Eastman Kodak was chosen, opting for a more traditional manufacturing process. Although both mirrors passed what later turned out to be flawed quality control, according to some scientists, the Kodak mirror was the better one. Despite this, Perkin-Elmer decided to use its own mirror. The telescope was originally scheduled to be launched in 1983. This date could not be kept due to delays in the construction of the optics. The final readiness for launch was reached in December 1985. Meanwhile, the Space Telescope Science Institute was formed at Johns Hopkins University in 1983 to operate the new telescope as part of the Association of Universities for Research in Astronomy. In the same year, it was renamed the Hubble Space Telescope, HST for short, after Edwin Hubble, who discovered the expansion of the universe. After internal problems had delayed the start by 2 years, the new start date of October 1986 could not be met either. The reason for this was the Challenger accident on January 28, in which all 7 astronauts died due to a material failure on one of the solid boosters. Since Hubble was to be transported on the Space Shuttle, the launch was delayed by another 4 years due to extensive upgrades to the other space shuttles. Finally, on April 24, 1990 at 12:33 UTC, the Space Shuttle Discovery lifted off with the telescope on board from Launch Complex 39B at Kennedy Space Center in Florida. The mission, designated STS-31, went smoothly despite the record altitude of 611 kilometers. The telescope was successfully deployed the next day and could be activated as planned. Although quality assurance measures were taken after the main mirror was manufactured, massive image errors were discovered as soon as the first light came on. According to specifications, a point target should have 70% of the light concentrated on a point. In fact, it was spread over a much larger area, massively reducing the scientific value of the telescope. Subsequent measurements showed with high certainty a strong spherical aberration due to bumps on the primary mirror. Once it was determined that the error was large and complex, NASA Director Richard Harrison truly ordered a committee of inquiry to be formed to further isolate and possibly fix the error. Upon inspection of the original corrector, which had been stored after the primary mirror had been delivered, it was found that one lens was 1.3 mm too far from another. Computer simulations were then run that calculated the effects of this error on the primary mirror. The type and extent of the results matched the observed aberrations of the telescope in orbit very precisely, so that the wrong lens spacing in the corrector was ultimately responsible for the primary mirror error. In the further course of the investigations, a large number of omissions and obstructive structures were uncovered in the area of quality assurance. Persons responsible for quality assurance were not integrated into the project team. There were no independent reviews by neutral branch offices. There were no documented criteria for the test to distinguish between failure and success. Quality assurance employees were not allowed access to large parts of the corrector's production. Because PerkinElmer used some new and largely untested computer-based techniques to manufacture the primary mirror, NASA commissioned Kodak to manufacture a backup mirror using more traditional means. However, since the spherical aberration was not detected at PerkinElmer before launch, the Kodak mirror remained on the ground. After the error was discovered, consideration was therefore given to recapturing Hubble with a shuttle and replacing the mirror with a Kodak-made one. However, this turned out to be extremely complex and expensive, so a correction system was developed that corrects the primary mirror error before the collected light reaches the instruments. It is called Corrective Optics Space Telescope Axial Replacement, COSTAR for short, and was installed on the first service mission 2.5 years after launch. It was only after this mission that the telescope could start its scientific operation without any bigger problems. However, COSTAR occupied one of the 5 instrument bays that were actually intended for scientific systems. Therefore, all the following instruments were equipped with their own internal correction system so that they could get the light directly from the main mirror without going through COSTAR. During the last 4th service mission, the system could be removed and replaced by a scientific instrument. Since then, primary mirror errors are no longer relevant, and Hubble could finally send us spectacular pictures. The telescope's images not only wowed the general public but also inspired a new generation of young people to pursue careers in science and engineering. The Hubble's success proved that space exploration could yield significant scientific results and capture the public's attention, leading to a renewed focus on space initiatives. Thanks for watching and for your support. If you like this type of longer videos, please make sure to let us know in the comments. Like and subscribe for more videos like this and science-related content in general.